Now we'll discuss how to measure the friction acting on a body. Here we can write that friction on a body which is placed on a surface can be measured by using a spring balance. You might have seen a spring balance in various go-downs for measurement of weights. Here you can see this is a typical spring balance in which on one side there is a hook and other side is connected or attached with a rigid support. On the hook, when some mass is hang, then due to the weight the hook is pulled down and the pointer of a spring balance is also displayed and it shows some reading. Now in this situation, if weight is increased, here you can see one more mass is added to the system, then the reading will further increase. So here we can write that more weight is basically the force due to gravity on the objects which are hanging. This implies more reading. And basically this reading is giving us an idea about the force which the weight is exerting on the spring balance. And by using this we can calibrate the spring balance and measure the mass which is hanging. Now similar spring balances are used for measurement of friction. Here you can see there is a realistic situation where a block is placed on a rough surface and it is attached with a string which is connected to a spring balance. Now initially as the string is slack, the spring balance is giving us 0 reading, and when this mass or the brick which you can see over here is pulled by applying an external force on the hook of the spring balance, the spring gets taut and the same force is applied on the brick. But due to roughness of the surface, a friction force appears in opposite direction and this does not allow the brick to slide if external force is small. When external force increases, you can see the reading of a spring balance is also increasing, giving us an idea about the amount of force which is applied on the spring balance, and indirectly it is applied on the brick. And we can see the movement when the brick starts sliding. That means this is the point where external force exceeds the friction. That's why it starts moving. And if it is at rest, the external force is completely balanced by the friction force because the two are acting in opposite direction. So here we can see at the point of sliding of brick, we can use the external force which is applied is exactly equal to the maximum value of friction, and as soon as we can see, as soon as the force exceeds this value, the brick starts sliding. That means friction is up to this level only, and this external force is basically the reading of the spring balance. Spring balance here we have connected just to measure the external force, and the value of external force is equal to friction at the point of sliding of brick. So you must be careful how we are measuring the friction on a rough surface. The same experiment can be repeated on different kind of surfaces. If the surface is smooth, the reading of spring balance will be less at the point of sliding of brick.